Now the chemical reactions of alcohol. So let's see one by one. So when you take alcohol like ROH, when you react this by sodium, right? Sodium. So what will happen here? 2 moles of ROH, H will be hydrogen gas will be liberated out, and here sodium will be placed, right? So RONA plus H2 hydrogen gas will be liberated out. Okay. If you do esterification reaction like in the acidic medium, that is H plus ion will be there, and if you use R dash C double OH, that is carboxylic acid, this process is known as esterification. Esterification. That is the reaction between alcohol and carboxylic acid. We will get ester, right? So R C O O R dash, and water will be released. Okay. Next is your when alcohol reacts with HX, that is alkyl halide, it will the water will release, and alkyl halide will be formed, right? Alkyl halide will be formed. Let's see the mechanism. See, I'm writing the mechanism here like ROH, right? You have ROH, that is your alcohol, lone pairs of oxygen. So here HX will give you H plus ion, right? And this H plus ion will attack this, this oxygen, right? So here ROH2 will form, right? And again, this is H plus and X minus. Again, when this halogen attacks this R, right, this alkyl group, then from here water will be released, right? Here the loss of water will occur, that is minus H2. And what will you get? Rx, right? This is the mechanism which is following, right, which has been followed in this reaction. Next reaction is your with PCl3, or if you add PCl5, and this can happen using PCl SOCl2, that is thionyl chloride. Okay, with all this, the alcohol will convert into alkyl halide. Okay, RCl. Okay, see, let's see the mechanism one by one. And what will be, yeah, the main product will be the same, but the byproduct will be different in all the case. When you use PCl3, you will get basically H3PO3, and when you use PCl5, you will get POCl3, and when you use SOCl2, you will get another byproduct. Let's see. Let's write here. Don't be confused. So when you use 3 moles of ROH plus 3 moles of PCl3, you will get 3RCl, plus your byproduct will be H3PO3, right? But when you use RPCl5, see PCl5 ROH plus when you use PCl5, you will get the same product, but the byproduct will be different. Like you will get HCl and POCl3. POCl3 is what? That is phosphoryl chloride. Got it? And in the case of thionyl chloride, that is SOCl2, RCl, again, this will be the same. And here SO2 will be formed and HCl will be formed, which will be in gaseous form, right? So this you will get is pure, in pure form, right? This is the best method of preparing this alkyl halide from alcohol. Next is your next reaction is your when see when you add concentrated H2SO4. So you know that concentrated H2SO4 is a dehydrating reagent, right? So it basically dehydrates. That is, dehydration will occur. That is the removal of water or the loss of water, you can say, and you will get RCH. You will get alkane. Okay. Next is your yes. When you treat alcohol with copper and you get give heat to it, so here dehydrogenation will occur, right? Dehydrogenation will occur, and you will get either aldehyde or you can yes, or either CR2CO, right? So see here, like yeah, when you have 1 degree alcohol, right? So it will convert into aldehyde, and if 2 degree alcohol is there, then it will convert into ketones, and if 3 degree alcohol is reactive, right? So the dehydrogenation product will be your alkenes. Remember that. It's very important. Okay. So the next reaction, chemical reaction of alcohol is uh, okay. So first do the oxidation. Simple, do the oxidation. What does CrO3 does? So basically, it's an oxidizing agent. It oxidizes, right? So when uh, alcohol will oxidize to RCHO, right? Either aldehyde or ketone, C2R2CO. Okay. Okay. See one thing. See one thing. If now here the question arises, when will it give aldehyde and when the product will be your ketone. So if your alcohol is primary, right? So the it will further first give aldehyde, followed by it will convert it into your carboxylic acid. Okay. And if your alcohol is secondary, then you will get ketones over there. Right. Hope you get it. Just let's see some examples. See, first example. Okay, let's say, let's take first primary alcohol, CH3, CH2, OH. So this is basically a primary alcohol. So when you do hydrogenation, that is when you add copper and heat will provide heat, then what will happen here? Basically, right. So here the removal of H2 will be done, right? So what we say, the removal of hydrogen, that is your oxidation. Here oxidation will happen, right? Oxidation will happen and you will get CH3, CH, right? That is primary alcohol will convert into aldehyde. Got it? Here oxidation happens. Okay, the next example is, let's take secondary alcohol, CH3, CH, OH. Here methyl group is attached, right? So this is secondary alcohol. Again, do the same thing, oxidation. The oxidation here, right? H2 will be removed out and you will get here CO and here CH3. What is this? This is ketone. When? So, um, when you oxidize this secondary alcohol, it will oxidize into ketone. Got it? Again, let's take an example of tertiary one. Okay, CH3, C, again here CH3, CH3, and here OH is attached. Right, this is tertiary one. Again, do the same thing, do the oxidation. So here, as you see, let's write it CH2 and H. Okay, so here what will happen is OH, H2O. H2O, loss of water will occur, right? So here, if the loss of water, H2O will be removed out and you will get alkene, right? Here, double bond will form and you will get this. This is basically alkene. Okay, these are the chemical reactions of alcohol.